Okay, some more practice for us. We have to divide 3x cubed plus x minus 5 by x minus 2. Now, there's a little bit of a trap in here. This thing is jumping from x cubed down to x. There's no x squared term here. So that means that we will create a dummy x squared term in our setting out so that our setting out doesn't give us a headache and make us potentially make an error. So you see what I've got here? 3x cubed plus no x squared plus x minus 5. Phasing these powers of x down by one at a time. Okay, now let's get going. What's the first thing we do? Yes, that's right. We divide the x into the 3x cubed and we get 3x squared. And now we multiply 3x squared by the x minus 2 and we get that. Okay. Now we do the subtraction. Okay, now you think in your head, what are we going to get as a result of this subtraction? Did you get plus 6x squared? I hope so. Otherwise you fell into the trap and that's not a good place to be. Okay, bring down the rest. We get that. Okay, degree 2, degree 1, keep going. Divide x into 6x squared. What do you get? 6x. Okay, let's do the multiplying of the 6x by the x minus 2. And we get 6x squared minus 12x. Now we do the subtraction. Okay, what did you get? Subtracting. Come on. Did you get 13x? And then you bring down the minus 5 as well. Good work if you did. Good work. Now, okay, degree 1 have to go again. Okay, we're going to divide the x into the 13x and get 13. And then we're going to do the multiplication of 13 times the x minus 2. We get that. And now we can do the subtraction. And what are we going to get? We're going to get 21. Therefore, that's the place to stop because this is now degree 0 and this is degree 1. So this is now our true remainder and it's our signal to stop, okay? So we can say that the polynomial here is equal to our divisor times our quotient plus the remainder, or if we want to divide both sides by the x minus 2 by the divisor, we can say that, okay? That's our answer. Now, for something completely different, let's have a look at a different way of doing polynomial long division. And we achieve this by doing what's called equating of coefficients. So you actually don't have to divide, just in case you hate long division, the process, or you just want an easier way of doing it. This can be for you, okay? But it'll just be up to you as to which one you prefer, okay? I like this one. I find it really nifty and easy to do. But some people don't like it, so just see how you go. Now, we're dividing 3x cubed plus 2x squared minus x minus 2 by 2x plus 1. Okay, now what you do is you set it out like this. You say, okay, on the left-hand side, you put your polynomial, and then you equate that to be equal to the 2x plus 1 times this. So it'll have to be a quadratic in here because this thing's a cubic. Okay, so you give these just generic pronumeral coefficients, ax squared plus bx plus c plus some remainder, okay, where a, b, c and r are all constants, okay? Now, the plot thickens. It's quite a beautiful technique, actually. So we can say, all right, you guys, from the right-hand side, we can say that the x cubed term is going to be, if you multiply this out, just the x cubed term, you can see that the only way you're going to get an x cubed term is from this being multiplied by that. You see, nothing else will give you x cubed. If you want to pause me and prove that to yourself, you'll see that that's right, what I'm saying. So really, the x cubed term from the right-hand side is 2a x cubed. Now, we say, wait a minute, but that has to equal 3x cubed. You see, we're equating coefficients. So we're saying that 3x cubed is equal to 2ax cubed, and therefore you can say, therefore, that the 2a must equal the 3, and therefore a must be 3 over 2. Voila! we worked out what the A was. And now we systematically work through the B and the C and the R in the same manner. So we could say, let's now go and have a look at the x squared term now on the right-hand side. Now, you're going to say to yourself, well, hang on a minute. This 2x times something over here would give me an x squared term. In fact, it would be when you multiply the 2x by the bx, because you get 2bx squared. And then you say, righto, there's no other term there that multiplied by the 2x, you'd get an x squared term. Now let's have a look at the 1, the right-hand term here. Well, if we multiplied that 1 by the ax squared, the first term in this bracket, you'd get an x squared term, in fact, ax squared, wouldn't you? So now I've worked out all of the terms, which if you did multiply this thing out, would yield x squared terms. So then you say to yourself, wait a minute, this is 2x squared, and therefore that 2x squared must equal what we worked out over here, the ax squared plus the 2bx squared, and we say that, okay? You're getting the hang of it? Therefore, we can equate the coefficients now, and we can say that the a plus 2b equals the 2. And we already know that a is 3 over 2, so let's substitute that. And we can say that 3 over 2 plus 2b must equal the 2. And we solve it now for Mr. B. So therefore, we know that 2b is equal to 2 minus 3 over 2, or a half, and therefore b must equal 1/4. How do you like it? Now, you might like the long division better. I really like this. I think it's a really nifty technique. But, you know, you make up your own mind, as I'm saying. Okay, now we're going to work through the x terms now. So what over here in the multiplication of all this, if we were to multiply it out, would yield just x terms? Well, again, this term and this term multiplied individually by one of these terms in here will give, each of them will give an x term. So if I multiply the 2x by the c, yes, I'll get an x term, which will be 2cx. Secondly, if I take the 1 and I multiply that by just the bx, I will get another x term, okay? So therefore, we've got 2cx plus bx on the right, and we've got minus x on the left, and therefore we can say that the minus x equals the 2c plus bx, and therefore, equating the coefficients, we can say that 2c plus b equals minus 1. Now, guys and gals, we have up our sleeve that the b equals 1/4, so therefore we substitute that in, and we get 2c equals minus 1 1/4, or minus 5 over 4, and therefore c must be minus 5/8. That's marvellous. Now we've got one more step to go, and we can work out what the constant term r is here, okay? So similarly, we can say from the right-hand side, if you look at this, multiplying all this out, the only constant term you'll get from multiplying these two brackets out is just c, and then you've already got the r. So therefore, the total constant term comes to c plus r, which we know equals, from the left-hand side at equating like terms, we know that must equal minus 2, okay? And therefore, we substitute the c equals to minus 5/8 into this equating of our like terms. We put that in there, and Bob's your uncle. Look at that. R comes out to be minus 11 over 8. And therefore, we've worked out what all of those constants were, A, B, C, and R. Okay?